Hello and welcome to the lesson. Right now is chapter 8, lesson 2, and we're proving triangles are similar by what we call angle similarity. So we're going to write that angle similarity. Now, you know I'm good on abbreviating things, so if you just write angle sim, that will be good enough. Now, we've already talked about angle similarity in previous lessons, so this lesson's going to go pretty quick. So what we're going to do right now is just do a little bit of a radical review before you guys have your quiz on this. So we're going to do a little bit of a radical review here. All right, so let's see, 128. All right, so the first thing, I grab my calculator, I do a couple things, and I check to see if 16 goes in here. And 16 actually goes in here 8 times, okay? So the square root of 16 is 4, but then I realize the square root of 8 is the square root of 4 times the square root of 2. So now I'm going to take 4 times, and the square root of 4 is 2, and then I still have root 2. So 4 times 2 is 8. So this is 8 root 2. And then I go, oh yeah, that's right. So I could have, if I would have noticed right away, taken the square root of 64 times the square root of 2, because 64 times 2 is 128, and gone right to 8 root 2. But either way, I need to see some work. I don't want you to go right to from the square root of 128 to 8 root 2. I need you to break it down. All right, number 2, when we look at that, kind of in your brains, a lot of you are just already looking at that and going square root of 100 and the square root of 121, because each one of those are perfect squares. So we get 10 over 11. Now this one, I would not expect you to show me any work, because most of you are going to recognize that the square root of 100 is 10 and the square root of 121 is 11. So number 2, you probably would just go right to that final answer. All right, number 3, what do we do here when you have a radical in the bottom? This is called rationalizing the denominator. Rationalizing the denominator. We are not allowed to have a radical in the denominator. So what I'm going to do is multiply by 1, and the square root of 5 over the square root of 5 is 1. This way I'm not changing the value at all. So I have 6 root 5 on the top, and on the bottom, the square root of 5 times the square root of 5 is 5. So this is my final answer. Always look and make sure that these do not simplify, these two numbers, which in this particular case they don't, but please make sure that you are checking for that. All right, number 3. When we do this one, I'm sorry, number 4, I saw the square root of 3. We're going to multiply by the square root of 3 over the square root of 3. So then on top, I get 21 root 3. And on the bottom, the square root of 3 times the square root of 3 is 3. So this is exactly why I said that in the last one. When you look here at 21 and 3, 21 divided by 3 is 7. So this final answer would be 7 root 3. So make sure you simplify whatever you can. All right, square root of 10, square root of 40. So how about I write that under one radical? So I have 10 over 40, because that is going to simplify to 1/4. Now, I basically have the square root of 1 over the square root of 4, and the square root of 1 is 1, and the square root of 4 is 2. So this simplifies to 1/2. All right, number 6, well, that ends up being 30 over, and the square root of 25 is 5. So 30 divided by 5 is 6. All right, 7 root 5 minus 3 root 5. So this is subtraction, so I need like terms. Root 5 and root 5 are like terms. Now we leave the root 5, And then we do 7 minus 3 is 4. So if I had 7x minus 3x, what would you get for an answer? And wouldn't you get 4x? Well, this x just happens to be a root 5 instead. All right, number 10. You cannot just combine these because we have a root 5 and a root 45. This does not simplify at all, so I'm just going to rewrite it. But this square root of 45 is the same thing as square root 9, square root 5. And the square root of 9 is 3. So we have 3 root 5 times this 2 in front. So this is minus, and 2 times 3 is 6 root 5. Now they're both root 5s, so 8 minus 6 is 2, and then leave your root 5. So this is 2 root 5. Alrighty, let's get into the lesson here. So angle similarity theorem. So we've talked about this before when we were getting triangles to be congruent. And we tried many different things. So we tried side, 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 angle, side, angle, side, angle, side. We did angle, angle, side. We did side, side, angle. And we did angle, angle, angle. Now these are the only ways you can put those letters together. And to get triangles congruent, this worked. This did not work, because if we think of a triangle that it's all equilateral and they're all 60 degrees, well, we could also make a triangle so that these are all 60 degrees, and those are definitely not congruent. One's bigger or smaller than the other. And this side angle we found out didn't work, because when we make this side over here, sometimes we could put it out there and get the triangle, and sometimes we could put it in here so that this side, now we get two different triangles here. So side angle did not work. But what we talked about was angle will always be similar. So if we look at these two triangles, they are similar. So anytime two angles in a triangle are congruent to two of another, we are definitely going to have similar triangles. Now, mathematicians are lazy. We know that C is congruent to F by what we call the third angle theorem. But mathematicians don't want to write angle similarity, because we are efficient and we don't want to write that last one. So it is just understood that they would be similar. So we just call this angle similarity. Okay, you have to have the similarity after, because if you just use the letters side, you are telling everybody that triangles are congruent. So if you don't put this word similar afterward, you are telling me that triangles are congruent. And we're not getting them congruent, we're working on similarity, scale factors, ratios. All right, so do we have enough information here? Let me number them so we know which ones we're talking about. So in 1, is that enough information? So maybe you want to stop, pause this, you go through all 4 of them, say yes or no, and then come back and replay it so that you're checking out your answers here. So the first thing I'm going to do is take 90 minus 64, and then I end up getting 26 in here. So let's see, this ends up being 26 and this ends up being 64. So this is yes, and it would be angle similarity. All right, so if this is 52, this is 52. Well, look at this big triangle right here. This big triangle. Does it have a 52 and an angle A? And then look at this little triangle. Does it have a 52 and this angle A? So this would be yes by angle similarity. All right, how about number 3? We've got a right angle. Do we know anything's parallel to anything? We don't know what angles things are at. We don't know for sure if this is a straight line or if it's off. So I'm not going to try that. If we knew that that was a straight line, then we would have some parallel lines, but no transversal. So this one is not. We don't have enough information here to get any other angles to be congruent. All right, how about number 4? Let's see, I think there's a couple different ways we could do that. Because this line is parallel to this line, we can use this transversal. So this angle is congruent to that one. And then we could say verticals here. So we could say angle, angle, similarity. Now someone might not use verticals. Someone else might say, hey, this is parallel to this, and we have this transversal. So this side, or that angle, is congruent to that, and we still have angle, angle, similarity. So either way you look at it, that one's going to come out to be true. All right, proving the two triangles are similar. So we're talking about this big triangle of WYU and the smaller triangle of XYZ. Is there any way we can get these triangles congruent? Well, both of them have angle Y in there. So we know angle Y is congruent to angle Y, so we know those are congruent. So now the next thing I'm going to do is take 180 minus 85 minus 45. So 180 minus 85 minus 45, and I believe that leaves us with 50. So now I can say YZX is 50 degrees because of the triangle sum, and then we're given YWU, we're given that information. So there's your given, and then there's the other angle by triangle sum. So now we have two angles congruent. Okay, so these two angles are going to be congruent, and that would make the two triangles similar. Remember, the single mark right here means similar by angle, angle, similarity. Notice that it says similarity, not just angle, 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 similarity. This step right here, if you didn't have that in there, I would probably not mark this proof wrong, so no worries there. If you get them congruent here and then they're congruent here, that's enough to say the two. All right, example here. We got a flagpole cast a shadow. So flagpole, shadow. So a flagpole casts a shadow that's 50 feet. At the same time, a woman standing by, she is 5'4". So what's that? 64 inches. Casts a shadow that is 40 inches long. Can we find this? So x over 50 is 64 over 40. So what I'm going to do is grab my calculator and take 50 times 64, and then I'm going to divide by 40. And I believe, let's see, can't find my calculator around here. All right, 50 times 64 divided by 40, and I got 80. 80 feet for the flagpole. All right, so that's using our similar figures, and corresponding parts are going to be in the same ratio, hence the reason we talked about proportions yesterday. So I think underneath here, yep, so they just draw the two separate triangles and show that they are angle, angle, similarity, and why we can use that. All right, we are ready for your homework time, so good luck.